Mathematics made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Target online class. Today we want to look at integration by trigonometrical substitution. That is, how do we integrate using trig substitution? That is what we want to discuss. But there are some things that we have to note, like what we have on the board, that at this point now, we shall only consider integrals which have one of the following. That is, we shall only consider the integrals that has one of the following. A, where we have square root of a squared minus x squared, or if the question is in form of 1 over square root of a squared minus x squared. But in this case now, we are going to use the substitution x to be equal to a sine theta. That's the substitution that we are going to make use of. We are going to see that by the time I introduce example. Then the second one, where we have 1 over a squared plus s squared. We consider this type of problems also. Then C, powers of sine x and cos x, or combinations of powers of sine x and cos x. So those are the three types of problems under trigonometric substitution that we are going to consider. So I'm going to give 3 examples. We are going to give 3 examples, then we are going to solve the examples. That is what we are about to do now. So example, let's say example 1. Evaluate or find the integral square root of 9 minus s squared dx. The second one, where we have integral 1 over square root of 1 minus s squared dx. Then the last example that we're going to take is integral dx all over 9 plus x squared. So these are the 3 examples that we're going to look at. So we start with the first one. A, the solution. How do we integrate integral square root of 9 minus x squared dx? So what are we expected to do in this case? That's what we are about to consider now. So if you have this type of problem, then from the introduction, we said we are going to, when we have integral a squared minus s squared, that we are going to use x to be, we are going to substitute x to be equal to a sine theta. That is, we say let x is equal to a sine theta from the introduction. But in this case now, what we have there is a squared. So if a squared is equal to 9, then a squared is equal to 3 squared. The power equal the base. Therefore, a is equal to 3. So in this particular question, our a here will be equal to 3. That is the implication. So I'm going to have x to be equal to 3 sine theta. That is what I'm going to use in this question. And of course, for me to be able to get, since I know x, I want to get the value of dx. So dx can be equal to, when I take this, this is product of 3 and sine theta. So if I pick this, I'm going to differentiate it. This is cos theta. Plus, if I pick this, differential of the constant is 0. So this is my dx will give me that. So the value of my dx is what I have on the board. That will be the value of my dx. dx is 3 cos theta. Then I can actually go back and rewrite what I'm given here. That is, where I have square root of, here I have square root of, I can go back and rewrite this, where I have square root of, from what we have there, I have square root of 9. I have square root of 9 minus x squared. So can I rewrite this square root of 9 minus x here? That's what we are. That's what I'm about to write now. So what I have within, can I still express it in form of sine and sine? Look at x is 3 sine theta, and I have 9 minus s squared. So what is the implication of this? This will be same thing as square root of 9 minus, what is x? 3 sine theta. S is 3 sine theta. So if I square this, I'm going to have 9 sine squared theta. That's what I'm going to have. That will be 9 sine square theta. That's what I'm going to have. Then from there, I can say this is the same thing as, I can bring out 9 to have 1 sine square theta. That's what I'm going to have. I'm going to have 1 minus sine square theta. So from what you have there, I can still proceed further. What is 1 minus sine square theta? We recall from fundamental identity that sine square theta plus cos square theta is equal to 1. So 1 minus sine square theta can actually be equal to cos square theta. So instead of 1, in this case now, I'm going to have 9. Instead of 1 minus sine square theta, I'll change it to cos square theta using the knowledge of trig. Then from this point down, square root of 9 is 3. Square root of cos square theta is because theta. So I've been able to rewrite everything here. This 9, square root of 9 minus s squared as 3 cos square theta. So what do we do from there? I'll just go back to the integral sign. You know, the question is integral square root of 9 minus s squared dx. So we've been able to rewrite square root of 9 minus s squared as 3 cos theta multiplied by what is ds? ds is equal to, when I differentiate it, this will be the theta, because it's ds the theta that we find. There will be theta here. So ds is equal to 3 cos theta d theta. So we have been able to restructure the question in this form. So then what do I do here? I can combine these two to have integral 3 times 3 is 9, 9 cos square theta d theta. So we have been able to restructure this the problem. Then whenever we have question in the form of square, we cannot actually look for the integral. So I will look for a way to rewrite that. Then how do I do that? We'll also recall from trigonometric identity that from what we have there, I can bring out that. This is what I'm trying to say. I said this is 9 can come out integral cos square theta d theta. It is somehow difficult or impossible to actually find the integral of cos square theta. Then what do I do here? How do I find the integral? I will recall that from fundamental identity, I will try and rewrite this. So how do I rewrite it? From my knowledge of trig, I can actually rewrite this. What I have here, I can rewrite it as what I have there. I can write it as, 9 is outside. I'll say 9 into brackets. I can write this as integral cos 2 theta plus 1 all over 2 dx d theta. I can do that. So how do I do that? Of course, cos square theta. Sine square theta plus cos square theta is equal to 1. But if you look at the double angle formula, under double angle formula, when we have when we have cos 2 theta, cos 2 theta can actually be expressed as 2 cos square theta. It can be expressed as 2 cos square theta minus 1, or 1 minus 2 sine square theta. Then if I bring this there, I will say this is cos 2 theta plus 1 is equal to 2 cos square theta. If I divide both sides by 2, this will cancel this. So instead of cos square theta now, the value of cos square theta will actually be cos 2 theta plus 1 divided by 2. That is what we are going to get from double angle formula. And that is what we have on the board. So please, before you can do anything on integration by trigonometric function, please go through my videos on trig. I think I have about 7 or 8 videos on trigonometric functions. So if you don't have proper understanding about trig, you may not be able to solve most of this problem. And that is nothing but the truth. So please, the knowledge of trig is actually required for us to be able to express this. So from here now, cos square theta d theta, I've been able to exchange it to cos 2 theta plus 1 divided by 2. Then from there, what do? We can actually find, I can bring out 9 all over 2. If I bring out 9 over 2, I'll be left with integral cos 2 theta plus 1 d theta. So that's what we have. So from there, we can find the differentiation of this. We can actually differentiate this. So that is, we have 9 all over 2 integral. We can expand this to be cos 2 theta d theta plus integral theta and integral 1. This is 1. That's integral d theta. Then if you do that, this is 9 over 2 outside. 9 all over 2 will now be equal to, if I integrate cos 2 theta d theta, I'm going to get, if I integrate cos 2 theta, if I integrate cos 2 theta d theta, I'm going to get sine 2 theta all over 2. So here I'm going to get, I can rewrite sine 2 theta as 2 sine theta cos theta all over 2 plus theta plus arbitrary constant. It is possible to do that. So please, vast knowledge of trig is actually required here, because what most of the things that I'm actually doing here, I'm making use of trigonometrical function to be able to do that. So this will cancel this. At the end of the day, I'm going to have, if I open up, I'm going to have 9 sine theta cos theta all over 2 plus 9 all over 2 theta plus arbitrary constant. But we are given our question in the form of x and not in form of theta, not in form of sine and cos. So we have to recall and go back to where we are coming from. You realize that when I introduce this concept, we are given that x is equal to 3 sine theta. That is where we started from. Of course, if x is equal to 3 sine theta, if I divide both sides by 3, sine theta can be equal to x all over 3. So we are going to see sine theta to be equal to x over 3. So I can actually sketch out this, something of this nature. Right angle triangle. So if this place is theta, sine is opposite all over hypotenuse. Sine theta will be that will be opposite x all over 3. So there's need for me to find the adjacent, for me to be able to rewrite everything in form of sine theta and cos theta and theta, for me to be able to write everything in form of x, because my answer must be in form of x, not in form of theta, because we are given the question in form of x. So if I do that, what will I get? I'm going to apply Pythagoras theorem here. I'll say 3 squared is equal to s squared plus this adjacent, this side that we are looking for, let's say y plus y squared. Then at the end of the day, I'm going to have 9 is equal to s squared plus y squared. So I can have 9 minus s squared to be equal to y squared. So if I take the square root of both sides, this will be square root of. So this side here will be square root of 9 minus s squared. That's what I'm going to get here. That is what I'm going to get here. Then from there now, I know sine theta already. That sine theta is equal to x all over 3. Then cos theta, cos is adjacent over hypotenuse, right? Cos theta is adjacent over hypotenuse. That will be square root of 9 minus s squared all over 3. That is what cos theta is. And of course, if sine theta is equal to what we have on the board, we know theta. Theta can be equal to arc sine of x all over 3. So we have gotten all the values that we are going to substitute for us to be able to find the value of what we have. So from there now, from what we have on the board, so this is where we stopped initially. But the answer is in form of x, not in form of theta. So I'm going to go back now from here. I'm going to have something of this nature. I will express everything in form of x. I will express everything in form of x, not in form of theta. So from there now, I'm going to have 9 multiplied by, what is sine theta? Sine theta is x all over 3. Now multiply by x all over 3. Multiply by, what is cos theta? Cos theta is square root of 9 minus s squared all over 3. That's what I'm going to get. Everything divided by 2. Plus 9 multiplied by, what is theta? Theta is arc sine x all over 3. That is theta. Okay. Then plus arbitrary constant. So from there now, I will have it to be plus arbitrary constant. That's what I'm going to have. So from there, I can just now say that integral square root of 9 minus s squared dx will now be equal to, if I write this correctly, if I express this correctly, of course, 3 times 3 will cancel this, will now be equal to x all over 2 square root of 9 minus s squared. Okay. Then plus, I will have, in this case now, in this second case, what do we have? No, here, there is half here. It's half theta. So there will be 9 over 2 here. So I will have 9 all over 2 arc sine x all over 3. Then plus arbitrary constant. So this will be the final solution to that problem. This will be the final solution to that. So the problem under example 1. So we go to the second one. You know, we are given 3 questions. We are able to solve one now. So we take the second and the third. So let's go to the second and the third question now. So we have been able to solve the first one. So we go to the second and the third. So please, so you have to follow this stepwisely for you to be able to actually understand the process. You have to follow it stepwisely. The B part of the question now is where we have integral 1 minus square root of 1 minus s squared dx. So how do we solve this? Of course, we are going to put x to be equal to a sine theta. In this case now, a is equal to 1, a squared is equal to 1. A squared is equal to 1, then a is equal to 1, square root of 1. So in this particular question, x can be equal to sine theta. That's what we are going to have. So if x is equal to sine theta, then what is the implication? Of course, we can find dx. dx d theta will be equal to cos theta d theta. If you cross multiply, dx will now be equal to cos theta d theta. So cos s is equal to this. Then what do we have there? Cos s is going to give us what we have there. Then from here, we have gotten the value of cos x. Then what about this? What we have? What we have here? How do we express what we have here? So from here now, let me move stepwisely so that you'll be able to understand what I'm actually trying to do. So from there now, I can go back to this question and say this is integral 1 all over square root of 1 minus s squared multiplied by, instead of dx there, I'm going to change it to cos theta d theta. But I still have something in the form of x there. Then what do I do here? How do I express this? That is the next step. How do I express this? So everything here, I will have integral 1 all over. Look at, from this question, we have square root of 1 minus s squared. We know the value of x that to be sine theta. So I'm going to have square root of 1 minus, if x is sine theta, then s squared will be sine square theta. That will be sine square theta. What is sine square theta? Sine square theta plus cos square theta is equal to 1, fundamental identity. Then if we make cos square theta itself a formula, so this will be cos square theta. Of course, square root of this, we cancel this. The final answer will be cos theta. So instead of square root of 1 minus s squared, I'm going to have cos theta here. Cos theta multiplied by cos theta d theta. Cos theta will cancel cos theta. At the end of the day, what am I going to have? I will have integral. I will have integral d theta. That's what I'm going to get there. I will have integral d theta. Then if I integrate d theta, I'm going to have theta plus arbitrary constant. So what is theta? If sine theta, from here, if x is equal to sine theta, then that is sine theta is equal to x, then what is theta? Theta will be equal to arc sine x. So from here, the final answer will be arc sine x plus arbitrary constant. That is what I'm going to get. So the final answer, if I integrate this now, I'm going to get, if I integrate the problem here, if I integrate this problem, my final answer will be arc sine x plus c, arbitrary constant. That's what I'm going to get. And that is the solution to the second problem. So we go to the last example. The last example that we are given under this, and we call it a day. We go to the last example, C, where we have integral dx all over 9 plus s squared. So in this case now, you know, the normal thing is a squared plus s squared. So if s squared is equal to 9, s is equal to 3. So here we are going to have x to be equal to 3 sine theta. That's what we are going to have here. In this case now, we are going to have x to be equal, no, in this case, when it is addition, it is tan. So here we are going to put x to be equal to 3 tan theta. That's what we are going to have. So if we have x to be equal to tan theta, then if we differentiate this, dx will now be equal to what? If x is tan theta, dx will be 3 sec square theta d theta. Please check my videos on differentiation of trigonometric function to be able to know what I have done there. Then if that is the case, so we go back and say 9 plus s squared will now be equal to 9 plus 3 tan theta all squared. So 3 squared is 9, then tan square theta. That's what we're going to have. We can bring out 9 to have 1 plus tan square theta. Of course, from fundamental identity, 1 plus tan square theta will give us sec square theta. So I'm going to have here, I'm going to have 9 sec square theta. That's what I'm going to have. So if I substitute all this back into the given question, which is integral, what is ds? ds is 3 sec square theta d theta all over 9 plus s squared. 9 plus s squared, we have gotten that to be 9 sec square theta. There will be some cancellation. We are going to make some, we are going to cancel out some things. Sine squared theta will cancel this 3 here 1, 3 here 3. So that at the end of the day, I'm going to have 1 all over 3 integral the theta. So at the end of the day, we have 1 all over 3 theta plus arbitrary constant. So what is theta? If x is equal to tan 3 tan theta, then tan theta will be equal to x all over 3. Then theta will be equal to arctan x all over 3. That's the value of theta. Theta is going to give us arctan x all over 3. So I'll substitute back and say 1 all over 3. Instead of theta, I'm going to have arctan x all over 3 plus arbitrary constant. And that is what we are going to have. So I would love to stop here because of our time. We are going to continue from there in our next video. Thank you, and God bless you all.
Mathematics made easy, no more fear.